So this is Daniel Rocco, and he's going to be speaking about Pushy, Postgres, and Python.
Thanks. Hey, everybody. Thanks so much for coming out to my talk today. So the topic is Pushy, Postgres, and Python. By way of introduction, my name is Dan. I work for a small business called Brightlink Technology. We're based out of Atlanta. And our mission is to help people prove themselves worthy. And the way that we do that is we provide software to the candidate credential and performance exam management spaces. And if that didn't make any sense to you, don't worry. It's actually not that complicated. It's a lot of user management, standard web application stuff. But we exist to really try to help people kind of achieve their dreams. One of the things I love about working at Brightlink is that I get to work on Python every day, a language that I love. I love the emphasis on readability, but mostly I love the community, and that's why I'm really excited to be here today and getting a chance to kind of talk about some stuff that I really love and care about with you folks. So I hope that you get something out of this. And toward that end, I wanted to start out with probably the most important question, which is why? And specifically, why are you sitting in the audience here interested in what I'm about to tell you? And I kind of think there's three reasons that you might be interested, not necessarily all overlapping. One is the recent development of always on, always connected social users, right? People that are, that want to share with each other. A lot of the social media that's out there, it's successful because it lets me share things with you, and it lets you share things back with me, and it lets people comment on the things that other people share. So there's this kind of very connected social aspect. And some of the technologies that I'm going to talk about today let you work with that in efficient and scalable ways. Another reason is that you have an application that you're trying to scale out. So this is kind of the technical argument. The first why was the social why. The second one is kind of a technical argument. Maybe you're running into a situation where, okay, you've got application servers that are, balanced or whatever, but you've still got a central data store, right? Well, what are you going to do with that? And then the third reason I call kind of the analytics why, right? Maybe that you're interested in learning more about your data, but you want to do it in a way that doesn't jeopardize the performance of your online application. So those are kind of the three whys that if you're out there and none of those connected with you, now is probably a good time to check out. Why I'm here, again, as I said, I love Python. I love working with software, as frustrating as it can be sometimes. But more than that, I love sharing information with people and being able to do that. So that's why I'm here. So if you want to check out after this slide, this is the one slide version of the talk, which is basically that if you're using Postgres and you didn't already know it, there is a data-driven push notification system built into it that you can have for free. Love, Dan. That's the whole talk. And so the rest of this talk is going to be an expansion of this idea that that if you're running Postgres, then there's this power that's built into it that I'm not sure a lot of people know about. I know I didn't for a long while I was working with Postgres, that offers some really interesting capabilities for distributed applications and for getting data out to people, again, in these kind of social environments where you want to be able to notify people, but again, you don't want to suffer from a huge load. By way of outline, I'm going to basically cover three things. First, I'm going to overview the observer pattern in general, the idea that kind of sets the stage for what this feature in Postgres does. Then I'm going to talk about the specific implementation in Postgres itself, how it works within the database system, and then finally we'll look at a couple of examples about how you do this in Python. And it turns out that working with this in Python is, as you would expect, ridiculously easy. So, with that, when I think about database systems, right, a lot of times applications that work with database systems deal with kind of demand-driven requests and responses. So if you think about kind of your typical queries in like a web application or whatever, something like, hey, I just got these two values, right? Do they match a username and a password in my system, right? That's kind of a very typical database query. Or maybe I want to do some sort of aggregate. So I've got this list of events, maybe joined with people, and so I want to do a count of that. How many people are signed up for thus and such an event? Right? But again, it's sort of a very demand-driven. I ask a question and I get an answer back. Or maybe I want to send an email to all of the users who happen to be in Ohio, right? So I do a query and I get back a list of email addresses for all of those folks. Again, these are questions that I ask the question, I get an answer back, and it's sort of done. But as I mentioned earlier, there's kind of a new paradigm that we also have to deal with. Not that those demand-driven kinds of requests have gone away, they certainly haven't, but there's this other notion of ubiquitous connectivity, right? This always-onness. My phone is always on, and it's always connected, and it's always getting information. And people expect and they want that, right? They want to know what's happening. But if you think about it, this isn't the same kind of question, right? This is like, hey, tell me when something interesting happens. So, I haven't gotten an answer, right? And the answer may come like 2 seconds from now. It may come 10 minutes from now. Who knows? There are some easy ways to implement this, right? So sort of your immediate reaction, if you don't know anything else, right? Well, perhaps the simplest way to do this is to use polling, right? To say, well, I'm going to set up some sort of loop, right? Some sort of infinite deal that just says, hey database, has anything interesting come in, right? And okay, there's nothing, and so I sleep for, however long. Hey database, has anything interesting come in, right? This is, in this kind of ubiquitous connectivity environment, this is really not great, right? Because most of the time, this is just wasted cycles. This is just wasted effort. I'm asking questions that the answer is, nope, nothing's changed. Nope, nothing's changed. Nothing's changed. And imagine, if everybody's phones did this to Twitter, right? I'm kind of not real. What would your server look like, right? We get server meltdown, and it puts you in this really awkward position of having to kind of try to guess. You either give up responsiveness by lengthening the polling interval, right, which lets your systems be healthy, right, or you live on the edge and you gamble with system health to increase, the responsiveness of the system. So it's kind of a lose-lose scenario, right? You're either making your people mad, you're making your systems mad, or you're making them both mad. And obviously this is not how you want to do this, right? A while back, folks came up with what's known as the observer pattern, and you've all seen it, but the observer pattern just kind of inverts this whole idea. Instead of asking for information from the repository, the database, or whatever, right? We turn that relationship around, and so in sort of the academic, egghead sort of definition, you have a subject, right? Which would be the database of posts or users or whatever. And when the subject, its job is whenever anything interesting happens, right? Send out a notice to whatever observers are connected to it, right? Pretty easy. The thing is, this is actually a really cool pattern because it splits up the responsibility for actions happening from the reaction to those actions, right? So instead of the subject having to know, oh, I'm going to put in a bunch of stuff to handle all the different cases that I might need to deal with, right? It just says, hey, something happened, and so all it needs to know is how to call the different observers that are interested in whatever it is that's going on, right? So it kind of creates this nice separation between actions that may be happening and the reaction to those things. And just as a note before I get to a concrete example, in Python, right, this is super duper duper easy. In a language like Java, you'd have to define a whole inheritance hierarchy where the observers were, inherited from some subclass. In Python, we have first-class functions. So these observers, they can just be a function that gets called. Again, I said that you've all seen this, right? If you've done any sort of web programming, right, or any kind of GUI event, GUI level programming, right, they're all observer-based. Then they may call it events or something like that, but it's the same idea. The idea being, okay, so I have a button, right? Well, the button doesn't know what all the different responsibilities are of the application when that button gets clicked, right? It knows how to notify people that, hey, I've been clicked. And so you can attach all these different listeners to it to say, well, when the button gets clicked, maybe fire off some logging message to the AB usage tracker or an analytics collector or maybe the form validator or whatever. So I can wire up all these different handlers to react to this event. And then the button, though, remains blissfully ignorant that anything is, of any of the implementation details of those. And I can, obviously swap them out and connect them and disconnect them at will without the button implementation having to change in the slightest. Right? So that's one real-world example. Real quickly, I wanted to highlight two others, Python-specific. Django actually has a signaling system. They call them signals in Django, but it has a system for this built in. And so it will tell you things like, at the kind of the ORM level, right, you can hook into things like, oh, a new model has been created, or a model's been deleted. At kind of a higher level of abstraction, there are things like the auth subsystem will tell you when a user has logged in, or when they've logged out, or when their authentication has failed, right? Again, this is an application of this same idea. The auth system doesn't need to know what your code wants to do when a user fails to log in, right? It just says, hey, this happened, and your application can then be written to do something interesting with that. Likewise, SQL Alchemy has a really nice event system. It's been in SQL Alchemy for forever. The version that they rewrote it in 0.7, and made it much better, much cleaner. And it does the same sorts of things where you can say, oh, well, this model object has changed, or this, this attribute has changed, or a new model has been created. So you can get all sorts of interesting information about that. I wanted to, and before I move on, I want to highlight, as with anything in software development, right, the observer pattern involves some trade-offs. On the positive side, right, you get to decouple actions that your system is interested in, right, things that happen, whatever they are, from the reaction to those things, which means that your handlers can all be focused on the one task that they need to do. If I need to send notifications to users and update some records and do some posts to my analytics tracker, those three responsibilities can each be handled by a separate handle that focuses on its one job, which is also distinct from the thing sending the messages. So it gives you this powerful way to split applications up and to break them by responsibilities. As you can imagine, that is a widely applicable sort of feature to be able to add. And therein lies both the power of the observer pattern and its danger. The danger being that if you overuse this, it can lead to some complex interactions, and especially like if you have cascades of events, it can make things pretty hard to track down. So you have to, be careful with how you apply this. But again, this is a pattern that's widely applicable And again, as you've seen, there are at least 3 kind of very different sorts of domains where we've seen this used. So that is the observer pattern in general. So let me now transition into, next I want to take a look at specifically how Postgres does it. And Postgres implements this publish subscribe mechanism through 2 commands called notify and listen. And it's actually quite straightforward. You listen on a message channel, you notify other listeners of events, and that's kind of it. And I'll note that despite this being a database system, these channels are not tied to anything database specific. That is, they're not related to tables or tuples or anything like that. Everything about this subsystem is independent, and we'll see kind of how you tie them in with the data part of it in just a minute. So the listen side, the observation side, is a really simple command. You say listen channel name. The channel name is just the band on which you want to hear messages or send messages. And it is an identifier in Postgres. So not a string, it's actually a Postgres identifier, which means that it has the kind of rules that affect identifiers in the database system. Basically don't use anything longer than about 63 characters, that sort of thing, and you can look up the documentation on all the limitations if you want. One weird thing is that in the way I've spelled it here, where I've said listen without quotation marks, Postgres treats those as case insensitive, so that's one little gotcha that you want to make sure you watch out for. But again, all this command is saying is, hey, anything on this process, listen, or on this session, listen for any messages that come in on this particular channel. The opposite end of it is the notify, which takes a channel again and an optional payload. The channel is, again, the channel that I'm sending the message out on, and I can either just send a message, hey, something happened, or I can actually, as of Postgres 9, I can pass along a string payload, which can be whatever you want, as long as it fits in 8,000 bytes. So that's it, right? Listen for things and then notify on the other side. So you can actually do this in the shell. Let me see if I can get my terminal connection here. And so what I'm going to do here is I'm actually going to set up 2 shells connected to the same database and show you what the interaction kind of looks like. So on this top one, I'm going to go ahead and say, listen to the Pi Ohio channel. As I just mentioned, I've spelled it out, capital P, Y, capital O, Ohio. But you'll see in just a second that it's actually not case sensitive because I haven't quoted it. So this session is now listening for notifications on this channel. And so now if I, from another process, say notify on that channel, nothing happens. The reason nothing happens is that the shell is only going to process notifications after the next command that actually talks to the server. So you have to actually do a select for it to show up. This is a limitation of the Postgres shell, not of like if you're connecting with Python. I'll show you how to set it up so you don't have to actually be polling, which would then kind of defeat the purpose. So you'll see that if I do a simple select, then it does the command, obviously, but it also tells us that it received this asynchronous notification from Pi Ohio. And if I come back and then I say, give it a payload, again, we have to come back up here and do a select statement, but then again, it's going to come in with this asynchronous notification, Pi Ohio, with payload. Wow, this is cool stuff. Pretty simple. Yeah?
You need to set up your channel with Pi Ohio in advance.
You don't. Nope. As soon as you as soon as you have a listener, that channel is sort of created out of thin air. So yeah, it just keeps a list of the ones that people are listening on.
Do you get an error if you notify your channel that doesn't exist?
No, you don't. So if there are no listeners, it silently doesn't send it, basically. There's an interesting interaction between this feature and transactions, which makes sense as long as you think about it carefully. And the key is that if you're in a transaction, right, what should happen if you send a notify from that transaction? Well, the behavior is defined, and the definition is that if you roll back a transaction, the notifications don't get sent, right? Kind of makes sense, but again, it's the sort of thing that you have to make sure that you kind of grok the interaction between these two features to make sure that if you're seeing something in your application that it's behaving, you know, that looks like weird behavior, this could be the reason. So basically, if I do a transaction, send out a notification in the middle of that transaction, it is not going to be broadcast until this transaction successfully commits. In this case, the rollback will cause that notification to be eliminated. Another interaction is that if you're listening on a channel and you're in the middle of a transaction, right? So let's say I start listening at the top, then start a new transaction, and I select some data from this monster view, or I update this other table with, 6 zillion indexes on it or whatever. Let's say that, the notification gets posted in the middle of a transaction. Well, it's not going to be delivered to that transaction until the commit. And again, this is kind of how the system defines the interaction between these two features. Probably the most typical use of this is to combine it with database triggers. If you've ever used a database trigger before, the idea is pretty simple. When something happens in the database, you can run a little function inside the database to do something. Maybe again, you want to, keep tabs on, the last logged in user, or who knows what you want to do. Basically, anytime you can set up a trigger to call a function whenever new records are added to the database, an update statement happens or whatever, and it's really granular, really powerful system. And with the notification, these two features dovetail really well in that you can set up a trigger so that in this example, whenever an insert happens on my user table, right, I send out a notification to any listening channel or any listening connections, hey, a new user has come, right? A new user has been added to the system. So this is an easy way for you to send out messages when interesting events happen. These triggers can be tailored so that they can run on insert, they can run on update, they can run on delete. Inside the function, you could filter it down based on certain criteria, and we'll see a little bit more detailed example in just a minute. All right? So that's kind of it for the Postgres side, okay? And again, most of this was kind of extra stuff around it. The two commands in this system are really just listen and notify. Listen to send to say, hey, I'm interested in events on this channel, and notify to actually send events out to people. All right, so last section, I want to talk about our particular use case and how we use this system and what we do with it. So in our system, we have a lot of jobs that come in that we don't want to process real time. So it might be something like a finance report that takes, some trivial number of seconds to run. Or we have cleanup jobs where we want to purge records on a periodic basis or something like that. And we want to run these things off of the main application server so that they're not clogging up our main application, right? We want to keep the main UI responsive for any tasks that are immediately initiated by the user, and minimize our perceived impact on the users of the actual application, right? So that's kind of our goal. We've got this, we've got the main sort of stuff that people are interacting with, but we also want to kind of do these other tasks that need to get done, but I don't want to do them while the user is sitting there waiting for the web page to return. And when we did this, we actually did a polling implementation the first time. And I was asked to rewrite it and came up with a solution based on this notify listen mechanism. And well, you might ask, well, why not some other technology? Why not Redis or Rabbit or something like that? Well, those DevOps guys are busy, right? They have stuff to do. Seriously, right? We're already on Postgres. And so we've got the system that all of our applications are already talking to. So in terms of new infrastructure, there wasn't any actually. It was just write the code to actually do the notify listen mechanism instead of the polling version. But in terms of actual deployed stuff, we didn't have to change anything. Another nice feature of this is that it's close to the data. Right, it's right in the same space with the data, and so it's kind of the information. You're dealing with the information expert here, right? The database is the closest to changes in the data, and so it's the logical place to start notifying other parts of the system that things have happened. So the approach that we took is that you have some sort of user actions that create some job. Again, I mentioned reports are kind of a big chunk of those, right? So we'll create some sort of usually financial or activity reports that might take a little time to run. And what we'll do is we'll offload those and send the user an email when the job is finished. So when the user says, "Hey, I want the Q3 financial report" or whatever, that'll kick off write a job entry into the database. The job will trigger a notification, and the worker farm, which is in a separate application, it's actually on a different machine, will pick it up and run it and save the results and do whatever is supposed to happen at the end. So this is another version of the trigger that this is actually closer to the one that we actually run. So in this example, I have a job queue table, which is just the record of these entries, right? And it's simple stuff like what the job is, right? And any extra data that the job might need to do its thing, that sort of bit. And so the trigger rule is just that anytime there's an insert on this table, fire off this function, and the function turns around and sends a notice on the job queue channel, right, which the worker farm is listening on, and then it actually passes in the name of the queue as the payload. So kind of an interesting bit here. The way that the trigger works is, you notice that I've said after an insert on this job queue table, execute the function for each row. Well, when you do that, Postgres inside the trigger function puts a variable in that scope called new, which is the row that has been inserted. So basically, that's the row that just got inserted into the database, so I can pull information out of it and do something with it. In this case, I'm sending off a message so that I'm not just sending out a generic, "Hey, a job has come" message. It's actually more specific. It's specific to the kind of worker that needs to pick it up. So the other workers can just go on, doing their thing. All right, so you're like, dude, you're, way into this talk and haven't shown us any Python yet, except for that goofy while loop at the beginning, right? Here's the Python side, and notice it's very short, and it's actually even less scary than it might look like, because it's basically doing, first it's doing some connection stuff. Right, those top 3 lines are just establishing a connection to the database. It's the same code you'd write if you were doing just normal queries using PsychoPG2. I mentioned earlier that the shell doesn't automatically pick up the notifications, right, until you issue another command. The way you get around that is you set the isolation level to auto commit, which tells the connection, okay, notify me as soon as any channel notifications come in. So The next section is the subscription section. And notice that I can subscribe to as many channels as I want, right? So in this case, I'm listening on 2 separate channels, the job queued message, which I just showed you, and a second one which allows us to send control messages that do things like, restart stalled workers and that sort of thing. So we're actually listening on 2 channels. And then we enter a loop. So this select is the operating system, well, it's the Python skin on top of the OS level command. Basically, this says block until there's a read on this connection, on this database connection, right? So that's kind of gross spelling, but that's what it means. And so what this process is going to do is it's just going to go to sleep until something happens on that con. I've actually got it on a timeout so that things like Control C still work. So it gets a chance to check that something else hasn't told this. Because if you don't do that, then you'll just sit there Control C and it won't stop. But basically, this is just telling it block until something happens, and we only get into this loop if the read actually returned that yes, there is indeed something on this channel. So the spelling there is, these are the channels I want to read from, write to, and I think the last one is exception. The end is a list back of channels available for reading, channels available for writing, and channels that threw an exception. Or sorry, not channels, but sockets. And so yeah, that's kind of the bizarre spelling, but again, it's just because this is kind of a thin layer on top of what the C libraries are giving you. Anyway, so once we're inside this if block though, that means that there has indeed been a notification. So next we ask the server, hey, give us all of the notifications that you've gotten, because it's possible that there may be more than one, right? It may have a batch of them. So the poll there just says, hey, grab all of the ones that I know you have, and I'm going to loop through them and pop them off the notify list one at a time. And in this case, I'm going to do something pretty simple, which is just to print them out. And the object that comes back just has a PID of the process ID of the process that sent the message, the channel that it's on, and the payload. Right. So again, it's not that much code, and most of it is just kind of setup stuff. And once you've actually got a notice, it sort of just tells you, hey, here's the information that was sent. So in our application, right, instead of a print here, what we do is we basically look at the channel and the payload to figure out what this message is, and then just do a dispatch, right? We say, oh, well, this means that, we need to wake up thus and such a worker and tell them to go get the data out of the database, or we need to restart thus and such a worker or whatever. Other things you can do, though, and there are lots of interesting applications for this, and so I kind of want to okay, I've given you a little bit of a use case. This is how we actually use this right now. But I also want to kind of do a little horizon gazing and see, well, what could we do with this system? How else could we use it? So one way that you can use this is there's actually a really cool example that does not require very much code, in which the example basically shows how to take a notification and push it from the database all the way to a web browser, right? And basically the idea is, well, the notification comes into your Python process, right, via this notify listen, which then turns around and sends it out on a WebSocket, right? So you've got push notifications from the back end all the way up to the front end. And actually some of the examples are pretty cool. They're like little real-time charts of graphs of information that's coming out of the database. This is the version this is actually eventlet. And as you can see, so the database side is pretty much exactly the same, right? The comment there is just that this is the same connection code that we saw on the last slide. And all it does is when it gets the notice, it relays it to this other thread via an inter-thread queue. And then the thread then turns around and it's got a WebSocket connection that it's holding on to, and it just says, oh, well, take the payload out of this message and send it off to the WebSocket, right? Piece of cake. And again, most of this is setup, right? We've got, and it's not even that much setup, right? If you stumble, so this example is actually from 2010. If you stumble across it, I will warn you that the implementation of Eventlet has changed. That Unicode there that's colored in red is colored in red because I spent like an hour trying to figure out why it's sending out all my messages in binary. It's because Eventlet says if anything that's not Unicode is binary. Do with that what you will. Obviously, we could use other, we could use WebSockets, or we could use another technology. If you wanted to do, if you wanted to do relaying to a back-end process, you might use something like ZeroMQ to route these messages, these notifications out of the database to something, or maybe something like a Redis pub sub. Lots of different ways that you could take this and get information from the database system and kind of relay it out to other spots. Some ideas. I mentioned mobile, and the sketch that I've just given there gives you kind of a pattern for how you might notify people of subscriptions in a social media kind of setting, right? So, I want to know when any of you send out a tweet containing PyOhio or whatever. Well, if my phone is connected to the app server via a WebSocket, right? So then that's one part of the connection. And the back end of the app is connected to the database. Then we can say, well, anytime a new tweet comes in, right, fire off a notification that pushes it all the way out to that application. And again, notice that I'm not doing any polling, right? The WebSocket connection is just going to sit there waiting for information to come down, as is the connection from the app server to the back end. Streaming, monitoring, and analytics, right? If it's not going to add any load, all of a sudden I can start thinking about, well, maybe we can do some interesting visualization of the data that's coming through our system, because I don't have to worry about it bearing down on the performance of it. Cache invalidation is another big area where if you're running like Redis on top of your app, right, this mechanism gives you a really, really easy way to do cache invalidation, because you can just look for new records or updated records, right, and push a notification out that says, oh, well, Redis, you need to invalidate these handful of keys or whatever. And if you want to get more ambitious, you can think about building kind of a microservice architecture out of this, right? Imagine building an application where distinct parts of your app are logically separated, right? So maybe I have my auth service as a standalone service, right? If I've got an easy way to connect things, then maybe I don't have to keep building these big monolithic applications. Maybe I can break them up to where the individual parts can all be focused on their areas of responsibility, and then I can use this mechanism to tell other parts of the system about things that they need to know. Quickly, I wanted to mention that, so like I said, our first version of the use case that I described was actually polling based, and I rewrote it about 1.5 years ago. It's been in production since then. It has processed millions and millions of jobs without hiccup. So it's been very, very powerful and very stable for us. The performance on actually sending notices is usually pretty good. The one caveat to that is that if you're in a transaction and you send a lot of notices, the notifications within a transaction are actually order n squared, right? So for every notice, you're doing n squared checks. And the reason is that Postgres behind the scenes is actually checking for duplicates. And so within a transaction, right, the more messages you send, the longer it's going to take you to send any individual message. that's something that I mean, you really have to hit a lot of messages for that to be an issue, but it is something to be aware of. So that is Pushy Postgres in Python. Thank you so much for your time, and I would be happy to take any questions if you have them. Yeah.
Back to the cache invalidation. Because I asked earlier if there's an error. If
Hello? Hello?
I just need to speak more closely. I asked earlier about whether or not a notify that doesn't have anything receiving it would give you an error. So I guess in the case of the cache invalidation, if for some reason the listener process that was handling those were down, is there a strategy for not losing the update so you know that the cache is still invalid whenever the listener comes back?
That's a really good question. From Postgres's perspective, the answer is no, right? That if it sends out if a notification gets sent and nobody is listening to it, it's not going to queue it up or anything like that. Yeah, you would probably need to mitigate that out of band. That have some sort of monitoring on the listener. But that's kind of once you get into cache invalidation, I mean, you really got to think hard about how you're going to structure that anyway. So I kind of think that's part of the hygiene for that, as it were. But yeah, Postgres itself, if you send a notice and nobody's listening, it's just going to, yeah.
Along somewhat similar lines, I'm wondering if there's a way, if you could guarantee only a single delivery of a message. I'm thinking of the case you had a thing where you'd send out a notification on a new user. And I was thinking, okay, well, maybe you want to send an email for a new user, but you only want to do that once. But you may also want to have multiple workers, so you can scale horizontally or anything like that. I don't know if this is a good fit for that type of problem.
So if you want to do that, then what you probably want to do is have the notification relayed to a broker that does the farming. So for example, have your listener be connected to the workers not via this mechanism, but via 0MQ, right? Which does have that sort of fair queuing notion. You're getting two advantages there. One, you're not sucking up a bunch of connections to the database, right? And two, you're leveraging 0MQ's really powerful capabilities in that area. There is a project called PDQ, I think it is, which is an extension of on top of Postgres for doing more of that fair queuing style stuff. I have not personally played with it. But so the sort of the native thing, no, you wouldn't want to use this for that, right? You'd want to have, or rather, you wouldn't want to use just this. PDQ is out there, but I don't really know anything about it other than that it exists. There's a question in the back.
The code example you had,
Yeah.
slides back, you had the function receiving a queue, but then it was sending a notice, and I didn't know where that notice came from.
This one?
Yes.
So
If you put notice, where does the notice come from?
here.
Oh, okay.
So screen space, right? So the idea is that you take that little queue put and it goes right here, right? So that's where it goes. Yeah, sorry. Yep. Yeah, and any other questions for me? All right, well, thank you so much.